In this video, we're going to talk about types of estimators, and then we are going to talk about the coefficient of variation. So let's jump into types of estimators. We have two types of estimators. One type of estimator is called a biased estimator. This is a sample statistic that does not target the true population parameter. It will regularly overestimate or underestimate the true value. So something like the standard deviation that is a biased estimator. If you have a sample and you calculate the standard deviation for the sample, that would not target the true population parameter. The range for a sample is not going to target the true population parameter. An unbiased estimator, it does target the true population parameter. So a mean does that. Proportions, so the proportion of a sample that it meets some criteria. Those would be unbiased estimators. When I think about biased estimators and unbiased estimators, I kind of think of it as a target along a line. So if this is the true population parameter, if you have a biased estimator, what will happen is if you took a bunch of different samples, those values for that sample aren't going to look like they were aiming towards that. They are regularly underestimating the true value of that population parameter. If you have an unbiased estimator, you took a bunch of samples, what's going to happen is the samples, they're not always going to hit, and in fact, probably very rarely will they actually hit the true population parameter. But if you took a lot of different samples, it would look like it was targeting that population parameter. You would have some values below it, some values above it. It would be reasonably well balanced with the number that were below and number that were above. It would look like it was trying to zero in on that value. So that's biased estimators, unbiased estimators. Some of those measures of center and measures of variation, you can look back and see which are biased and which are unbiased. The other thing I wanted to talk about here real quickly is the coefficient of variance or variation. This describes the standard deviation relative to the mean as a percent. So you take the standard deviation, divide that by the mean, and multiply that by 100%. So if we wanted to find the coefficient of variation for those scores in the Kansas City Chiefs games based on earlier examples, we previously found the mean for that sample set was 18. We found the standard deviation for that sample set was 7.79. And so if we want the coefficient of variation, we're going to take our standard deviation, 7.79, divided by the mean, times 100, so that we convert it to a percent. We get something like 43.28%. 43.28% is our coefficient of variation. Next time, we're going to take a look at measures of center. We'll catch you on the next video.